everyone, welcome back to Horse Patterns. In the last few videos, we talked about two key design patterns that help separate business logic from the rest of our code, making our software more maintainable and scalable. Before we move forward with even more patterns that simplify our code, we need to introduce a fundamental principle in software architecture: domain-driven design. In today's video, we're diving into this powerful approach that helps software development teams align architecture with business rules and real-world needs. So, what actually is domain-driven design? DDD, introduced by Eric Evans in his book Domain-Driven Design, Tackling Complexity in the Heart of Software, provides a set of principles and patterns to effectively model complex business logic. By understanding DDD, we can build systems that are more intuitive, scalable, and easier to maintain. Let's break it down and see why it's such a game changer. But what actually makes it special? DDD is both a strategic approach and a set of tactical patterns for designing software that models complex domains. It helps teams structure and implement software systems that are flexible, maintainable, and aligned with business needs. DDD is based on some key principles: a deep understanding of the business domain, clear communication between developers and business domain experts, a model-driven approach to software design, reducing complexity by keeping business logic isolated. Instead of treating software as just code and infrastructure, DDD encouraged developers to think in terms of business concepts and use those concepts to drive software design. In order to create good software, you have to know what that software is all about. You cannot create a banking software system unless you have a good understanding of what banking is all about. One must understand the domain of banking. This insight highlights the core philosophy of DDD. Before writing a single line of code, developers must gain a deep understanding of the problem domain they are working on. This ensures that the software reflects real-world business needs, making it more efficient and effective. Why is domain-driven design so important? It solves complex business problems. DDD is especially effective in domains with complex business rules, such as finance, healthcare, and logistics, because it models systems to reflect the core dynamics of the business accurately. Improves communication. Through the use of a ubiquitous language, DDD fosters a shared understanding between developers and domain experts, minimizing miscommunication and aligning goals. Enhances maintainability and scalability. By organizing software into clear bounded contexts, DDD enables modular adaptable systems that are easier to evolve and maintain over time. Supports modern architectures. DDD complements architectures like microservices and event-driven systems by promoting flexibility and loose coupling. Aligns code with business needs. Continuous refinement of the domain model ensures the software remains closely aligned with changing business requirements, reducing costly rewrites and misunderstandings. Now, let's go over the pillars of DDD. Ubiquitous language is a shared, domain-specific vocabulary consistently used by developers, business experts, and stakeholders to ensure clear and effective communication. It is explicitly defined and continuously refined as the domain evolves. It is applied across code, documentation, and discussions. It prevents misunderstandings by ensuring that everyone, technical and non-technical, speaks the same language. Take this as an example. In an e-commerce system, rather than using a generic term like order, the team collaborates with business experts to adopt precise terms such as purchase order, shipment, and payment transaction, reflecting real business concepts accurately. What are the main benefits from ubiquitous language? Eliminates miscommunication, creates consistency across teams, makes the codebase easier to understand. A bounded context defines a clear boundary within which a specific domain model is valid. It ensures that terms, rules, and logic are consistent and meaningful only within that context. In large systems, different parts may interpret the same concept differently. Bounded contexts help maintain clarity by isolating these interpretations. They offer several benefits. Keep models focused and cohesive. Prevent interference from other parts of the system. Minimize conflicts between teams working on separate domains. Let's take a look at an example. An e-commerce platform. In an e-commerce platform, you might identify several subdomains, each forming its own bounded context. This is the customer, a supporting subdomain. This subdomain manages components like customer profiles, addresses, and preferences. Its primary role is to support core operations such as order processing and personalized user experiences. While essential, it doesn't differentiate the business directly, hence it's classified as a supporting subdomain. The order is our application's core subdomain. This is the heart of the system. It manages the full order lifecycle: creation, payment, and shipping. It includes the core business logic that distinguishes the company from competitors. Because it directly drives revenue and customer value, it's considered a core subdomain. And finally, we have the inventory, a generic subdomain. This subdomain handles stock, product availability, and logistics. It typically follows industry standard patterns and is often supported by third-party tools. Since it provides necessary but non-unique functionality, it's categorized as a generic subdomain. Each of these is a distinct bounded context, meaning order in the order context is not the same as order in customer. Each context has its own domain model and business rules. Reduces dependencies and confusion across the system. Now for the context map. Since multiple bounded contexts exist within a system, they need to communicate with each other. Context map helps define how these contexts interact. There are multiple types of context mapping relationships. Shared kernel. Two contexts share a small, carefully agreed upon part of the domain model. While each retains ownership of its own context, any changes to the shared kernel require close collaboration to avoid breaking changes. Partnership. Both contexts are highly interdependent and must work in close alignment. Changes in one context often require synchronized changes in the other. Trust and ongoing communication are key. Customer-supplier. One context, the supplier, provides functionality or data, such as an API, which in another context, the customer consumes. The upstream, supplier, dictates the model, while the downstream, customer, must adapt accordingly. Anti-corruption layer. A protective layer between two contexts that translates and adapts models. It ensures the downstream context isn't affected or corrupted by the upstream's internal model, preserving autonomy and domain purity. In this example, the customer and order contexts use a shared kernel. That means they share a small, carefully managed part of the domain, like customer ID and addresses. Since customer is upstream, any changes there require close coordination with the order context. On the other hand, the order context communicates with inventory through an anti-corruption layer. Inventory is the upstream, but order protects itself by translating data and keeping its domain model clean and independent. This setup ensures strong boundaries, flexibility, and safer evolution of each context. This brings us several benefits. Helps teams work independently, reduces coupling between different domains, defines clear integration boundaries. In this journey through domain-driven design, we're going beyond theory. We'll dive into key patterns like the domain model, along with the concepts of aggregate roots, entities, and value objects. We'll also explore other important patterns like domain events and more. By understanding how these concepts work together, You'll be able to design and build robust, maintainable software systems with confidence. In conclusion, domain-driven design is an effective way to manage complexity in software development by keeping the focus on the business domain. The ubiquitous language ensures effective communication. Bounded context defines clear domain boundaries. Context mapping helps different parts of the system integrate smoothly. Have you used the DDD in your projects? Let me know in the comments. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more awesome software design content. Thanks for watching, and I'll see you in the next one.